Today I'm going to take a look at finding the derivative of f of x equals the square root of 3x to the third plus 2. So the first thing you want to do when you're taking the derivative of something like this is you want to rewrite it with a fractional exponent. So I'm going to rewrite this as f of x equals, in parentheses, 3x to the third plus 2, all being raised to the 1/2. So if you have anything with a square root, so like the square root of x, that can be rewritten as the x to the 1/2. Same thing if you had like the cube root of x. You can rewrite that as x to the 1/3. Fourth root of x, you can rewrite that as x to the 1/4. So whatever the degree is here, it just becomes the denominator in the exponent. So now that we've established that, we are able to now take the derivative. So how do we take the derivative of a scenario like this? Well, we have to use chain rule. So the chain rule is we take the derivative of the whole function. So that's going to be 1/2. So this is just coming down. So we're thinking of this as like x to the 1/2. If you were asked to take the derivative of x to the 1/2, you would do 1/2 times 1 because the coefficient is 1. So 1 times 1/2 is 1/2 x, and then you'd subtract 1 from the exponent. So this is 1/2 minus 1, which is over 2, and then this becomes 2. 1/2 minus 2 over 2 is negative 1/2. 1 minus 2 is a negative 1, negative 1/2. We're taking that same concept, but instead of just it being x, it's everything in the parentheses. So it would be 1/2 3x to the third plus 2 all being raised to the negative 1/2, and then we have an extra step there, but that's what we're doing here. We're just taking the derivative of the whole function as if it were just x being raised to the 1/2. So I worked that out off to the side there. So this is going to become 1/2 times 3x to the third plus 2 all being raised to the negative 1/2 times the derivative of the inside of the function now. So now I want to take the derivative of 3x to the third plus 2. So the derivative of 3x to the third plus 2 is going to be 3 times 3, which is 9, x, and then this becomes 3 minus 1, which is 2, so 9x squared. 2 is a constant, so that drops out. Now it's just the cleanup process. It's that rewriting, moving some things around. So I notice that I have, first of all, I have this raised to the negative 1/2 there. So that's going to come down. Now I also notice that I have 9 times 1/2. And since 9 divided by 2, we can't really divide that. We're just going to leave it as 9 over 2. So I'll have 9x squared over 2. And then this term, remember I said right here, this term has to come down because it's a negative square root. Sorry, it's not a negative square root. It's raised to the negative exponent. So that means it's a square root on the bottom. That has to come down, and then you can rewrite it as a square root. But this is going to be 3x to the third plus 2 being raised to the positive 1/2 on the bottom. And then you can take this a step further. And let me just move some things over here. You can take this a step further and rewrite this as 9x squared over 2, and then rewrite this as the square root of 3x to the third plus 2. That's a possibility too. I personally, if I was grading this, I would be okay with this. Just leaving it with that square root, the fractional exponent there. But this is 100% fine though, but I don't know, it just kind of depends on your teacher or what you're trying to accomplish here, if like how much they would want to rewritten. There's absolutely nothing wrong with this version, but you could technically write it like that also. But those are the exact same answers. So recap here, taking the derivative, we want to use chain rule because we have this whole function of 3x to the third plus 2 being raised to the 1/2. So 3x to the third plus 2 is all being raised to the 1/2. So then you have to use chain rule, which is 1/2 times 1, derivative of the inside, and so on. So that's the chain rule.